My report is devoted to the influence of the sun on self-organization of water molecules on the day and night sides of the Earth. This influence explains the water memory mystery and the Štorm-Гласс mystery. The mass of the sun is about 750 times larger than the mass of all planets rotating around it. And the Earth is just a fine grain of sand compared to the sun. The solar energy exerts a very strong influence on the Earth. It is sufficient to say that even the earthquakes on the Earth are modulated by the sun. This slide displays the influence of the solar wind, which is a stream of particles, mainly electrons and protons. In contrast to electromagnetic oscillations, the solar wind is absorbed by the atmosphere and doesn't reach the surface of the Earth. Nevertheless, the solar wind exerts a very strong influence on the Earth. In the upper atmosphere, the solar wind generates secondary particles, muons. We have found that self-organization of water molecules and the stability of water clusters strongly depend on the intensity of muon flow, which constantly changes depending on the variations of solar activity and distribution of solar energy due to the rotation of the Earth around its axis and around the sun. We have devised a chemical method which allows measuring the influence of the sun very precisely. This method is shown here. On mixing water with organic solvents, for example with acetonitrile, we do not receive a solution of single water molecules in acetonitrile. Instead of this, the formation of water clusters in acetonitrile takes place. We have found that muons generated by the solar wind destroy water clusters, and when the solar influence decreases, clusters reunite again. Small clusters are chemically much more reactive than large ones because they contain a lot of free hydroxyl groups. That is why, under the constantly changing influence of muons, the same solution of water in acetonitrile can have very different chemical reactivity because it can consist of a small number of large passive clusters or large number of small active clusters. To determine quantitatively the chemical reactivity of water clusters under the influence of muons proved possible by measuring the rate of hydrolysis of triethyl phosphate 1 into diethyl phosphonate 2. The conversion rate can be quickly and accurately measured by phosphorus nuclear magnetic resonance. Is it shown here? We have found that this reaction depends on the rotation of the Earth around its axis and doesn't obey the law of chemical thermodynamics. At constant temperature and concentration, the rate of this reaction depends on the position of the sun in the sky and displays distinct diurnal variations. In the morning, the reaction rate is lower and rises by noon up to 2-4 times. And when it slows down again, we noticed that the range of diurnal changes is not constant and can vary on different days throughout the year. In summer, when the solar influence is higher, the diurnal variations were more pronounced than in winter. That is why we made a supposition that the rate of hydrolysis may depend also on the rotation of the Earth around the Sun. For this reason, in January 2015, we started regular measurements of the rate of hydrolysis of triethyl phosphate in acetonitrile. This year was in the middle of the 11-year solar cycle, and the solar activity was very high. It was found that this reaction is highly dynamic, and its rate displays very large annual variations. In January, as you see here, the reaction was slow and started to grow gradually in March. At the end of June, a sharp rise occurred, and in early July, the reaction rate was record-breaking. From September to the end of the year, the reaction rate slowed down again. In December, the rate didn't return to the beginning of the year and exceeded it about 2-3 times. The acceleration of the hydrolysis in the summer and slowing down in winter means that the influence of muons on water molecules depend on geographic latitude and can be different in northern and southern hemispheres. Thus, in 2015, the rate of hydrolysis of triacyl phosphate in acetonitrile changed with a very wide range. The difference between single experiments in January and in July reached 200 times. Further measurements showed that the annual variations in the rate of this reaction are different each year and correlate with the variations in solar activity during the 11-year solar cycle. In 2016, a significant summer acceleration of this reaction took place again. In this year, the acceleration was very intensive already in April and May. It lasted till the end of July, and after some slowing down, one more acceleration of a shorter duration and smaller intensity took place. In the second part of September. In 2017, the rate of this reaction continued to remain very dynamic. However, a noticeable lowering of activity was observed. The annual difference between winter and summer, as you can hear on this slide, became less pronounced. That year, another interesting phenomenon was observed on August 21. A solar eclipse took place, immediately after which the rate of hydrolysis decreased sharply for 5 days. This confirms the influence on muons. In 2018, the slowing down of the reaction became especially strong, and by the end of the year, the reaction rate decelerated unprecedentedly. Against the background of low rate, 4 times in June, July, November, and December, the extremely sharp acceleration of short duration took place, which could be caused by the coronal mass ejections on the Sun. In September 2018, Studies were simultaneously conducted in Stuttgart in Germany, 1,500 kilometers away from Kiev. In both places, the diurnal deviations were observed. The average rate in Stuttgart was constantly about 2 times higher than in Kiev, which can be accounted for by the difference in geographic latitude. In 2019, a further decrease of the rate of hydrolysis was observed. The summer acceleration took place again, however, it was much, much less pronounced. Thus, regular measurements over 5 years showed that the annual rate variations are different each year, and from 2015 to 2019, a general deceleration of the reaction took place. This deceleration is in a good agreement with the decline in solar activity in the 24th 11-year solar cycle, started in December 2008 and ended in December 2019. In January 2020, the new 25th cycle began, and the solar activity started to grow. This was also observed in the hydrolysis of triethyl phosphide. In the first 5 months, the rate of this reaction remained very, very low, and then in May, it started to grow very intensively. These results convincingly confirm that the water activity is modulated by the 11-year solar cycles. It is important to note that exactly at very low solar influence between the two 11-year solar cycles, the coronavirus epidemic took place. Our results explains another interesting finding, that the annual growth rings in trees are organized in 11-year sequences. That was found in one rest of one tree over 1 million year old in Germany. It was shown here. Thus, the solar wind influences water clusters by means of muons. Muon flow displays the same diurnal and annual variations as the hydrolysis rate. Underground and during solar eclipses, hydrolysis slows down. Muon flux is anisotropic, so the rate of hydrolysis depends on the geometry of solution and the position of the sun in the sky. These numerous, almost daily experiments yielded another very interesting unusual result caused by the anisotropy of the muon flux. We noticed that the same reaction solution reacted at different rates in a 5 millimeter NMR tubes and in a 20 milliliter jar. This difference is constantly changing and can reach 5 times. Moreover, the rate can become diametrically opposite during the year. Sometimes the rate is higher in the tube and sometimes in the jar. The difference between these vessels is their geometry. The jar has a much larger top surface than the vertical NMR tube. Since the muon flow is anisotropic, it means that the vertical and horizontal muon flows should exert different influences on the jar and on the NMR tube. Taking this into account, it was logical to assume that the influence of muons on water clusters should depend not only on the geometry of a solution, but also on its position in space. And the reaction should have different rates in 5 mm NMR tubes directed vertically and horizontally, since the upper surface of a horizontal tubes is much larger than in a vertical one. Indeed, this assumption was easily confirmed experimentally. These results were the obtained results were very interesting. They shed light on the long-standing idea that different irritations of the human body during sleep have different effects on health. So the rate of hydrolysis multidirectional tubes are always different during the daytime. This difference depends on the position of the sun in the sky and changes during the day. Here are the results obtained in Kiev in July 2020. At noon, when the sun shines perpendicular to the horizontal tubes, the rate in them is the highest, while in the vertical tube it is the smallest. And this difference can reach 6 times. And at sunset, the sun shines along the east-west line, perpendicular to the vertical tube, and the rate ratio becomes opposite. The highest rate at sunset is in the vertical tube, and the smallest rate is in the east-west tube. Further investigation of this phenomenon gave very interesting and unexpected results. The conversion rate in multidirectional tubes at night turned out completely different. It was logical to assume that when the sun irradiates the opposite side of the Earth, the rates in differently directed tubes should become equal in all tubes. But the experiments didn't confirm it and showed that, that at midnight, the distribution of rates in differently directed tubes was exactly the same as at the middle of the day, at noon. In the vertical tube, as you see, the reaction was very low and much higher in east-west and north-south tubes. And this was also confirmed in September. In September, at night, the vertical tube was again the smallest, and in east-west and north-south horizontal tubes the largest. This means that the sun induces some kind of radiation on the night side of the Earth, vertically from underground. This is the only possible explanation for this phenomenon. This phenomenon requires detailed study on different places on the Earth and on different latitudes. Influence of the sun on water explains mysterious phenomenon Štorm-Гласс and the water memory also. Štorm-Гласс is a solution of camphor in water-ethanol mixture. It was found approximately 200 years ago that the amount of crystals of camphor in this solution changes very dynamically and in a very large range. And nobody, it was supposed that this is somehow connected with the change of weather. That is why this ampule was named Štorm-Glас. But we have found that the explanation of this phenomenon is very simple, and also explains by the influence of the sun. So, Štorm-Glас, as I have told you, is a solution of camphor in water-ethanol mixture. Camphor is soluble in ethanol, but insoluble in water. But water-ethanol mixture under the influence of the sun can also consist of a large number of small water clusters or small number of large passive water clusters. That is why when the number of water clusters increases, camphor falls out of the solution. And when the solar activity decreases, the number of clusters becomes smaller, and camphor dissolves again. This is a very simple explanation of this phenomenon. This phenomenon, the influence of the sun and water molecules, explains also the water memory mystery. Water memory is not always reproducible and is considered as pseudoscience. No one could imagine that the cause is outside the Earth. Water can copy its clusters and other molecules and retain their biological properties only under low solar influence when water clusters are stable and large. We confirmed this experimentally. We have found that even 0.02% water in commercial acetonitrile forms different clusters under the influence of the sun. Bulk water added after that to such commercial acetonitrile copies these initial clusters and acquires different hydrolytic activity depending on the location of the solvent before adding water. For example, you can see here that when acetonitrile was on the roof of the large building, then the added water after that hydrolyzed triethyl phosphate to 32%. And when the acetonitrile is in the basement of this large building, then the added water, the rate of hydrolysis was approximately 4 times lower. One more very interesting experiment, which also confirms the ability of water to copy its clusters and other molecules, is the following. When we take commercial acetonitrile and add to it water in 5 small portions, then the reaction, the hydrolysis of triacylitrile will proceed much higher than when we add the same amount of water in one large portion of water. It confirms that when we add water in small portions, the first portion copies the initial clusters, and every next portion will copy the previous portion and remain very small. This is very interesting, and this can be easily confirmed experimentally in any laboratory. So, conclusions are the following. The structuring of water molecules depends on the activity of the sun, its position in the sky, and geometry of the solution, and its position in space. An accurate measurement of solar influence has been developed. An unknown influence of the sun on the night side of the Earth was discovered. And this influence should further investigated. The mystery of water memory and Štorm-Гласс is explained. Measurements of in different places on Earth will provide important information for biology, chemistry, physics, and the environmental science. So that is all what I was going to tell you. Thank you very much for your